All right, so we are welcome once again to the third week lab. Now, today we are learning how to prepare molar solutions, and then we are learning acid-base standardization of solutions. Very important. Now, these are two key things that we have to take note of, because then we'll be applying them in every single experiment. Now, in every single experiment, you'll be asked to prepare molar solutions, and then in any other experiment, you'll be asked to standardize solution before using them. So we have to pay key attention to these areas. Now, before we start these discussions, we have to define some of the terms that we use to express concentration in chemistry. The first one is molarity. Now, usually the unit will help us to define. So molarity is mole per dm cube or mole per liter, right? Now, mole per dm cube, and so the mole is amount of substance, and then the dm cube is volume, right? Or liter. So if we talk about molarity, we are talking about the amount of substance in 1 liter of a solution, right? Or 1 dm cube of a solution. Now, the next one is molality. Now, molality will talk of the total moles of a solute contained in 1 kilogram of a solvent. And so molality is expressed as moles over kg, right? So the moles of the solute in the mass or in 1 kg of the solvent, not the solution of the solvent. The next term is normality. Normality will talk about the number of grams or moles equivalent of solute present in 1 liter of a solution. And so we are not talking about just moles or grams. We are talking about the grams equivalent, and we are talking about the moles equivalent. Now you get to understand these ones more when you are talking about normality, actual normality in chemistry. Generally, calculating in normality is very simple. It's very simple. Now, next one, ppm, parts per million. Now, that is the number of units of mass of a solute per million part of the total. And so we are talking about the number of units of mass of a solute per million parts of the total. That is what we call parts per million, right? The next term is volume strength. Now, volume strength is a quantity that is peculiar to hydrogen peroxide. And so you hear about this when we are talking about hydrogen peroxide. Now, if we say hydrogen peroxide has 1 volume strength, it means if you pick 1 volume of it, it will produce 1 volume of oxygen gas. It will produce 1 volume of oxygen gas. That's what we are seeing, right? Then we have other percentage expression of concentration. The first one is percentage weight in weight. It will be the mass of grams of the solute over the mass in grams of the solution. Percentage weight in volume will be the mass in grams of the solute over the mass, over the volume in mils, right? The volume in mils or milliliters of the solution. Then the last one, the percentage volume in volume will be the mils of the solute over the mils of the solution. Now, because we are talking about percentage, we are talking about out of 100. So if I express anything in percentage concentration weight in weight, it means it is that mass in 100 grams of the solution. If I express it in percentage weight in volume, it is that mass in grams over 100 mils. So this is over 100 grams, this is over 100 mils. This is also over 100 mils, right? Good. So assuming I have 9 percentage weight in weight, that means I'm talking about 9 grams of the solute in 100 mils of what? in 100 grams of the solution. If I talk about 9% weight in volume, percentage weight in volume, I'm talking about 9 grams in 100 mils, right? If I talk about 9% volume in volume, I'm talking about 9 mils in 100 mils of the solution. Very simple. Good. Now, molarity has been explained again for us. So molarity refers to the amount of substance in moles present in 1 liter or 1000 ml or 1 dm cube of a solution. Now we are saying that generally amount of substance in 1000 mils will be 1 molar of a substance, right? Now we know that the molarity is moles in volume, right? So C is equal to N over V. Very simple. Molarity M is equal to N over V. Now, but then we know mole is also equal to M over capital M, mass over molar mass. And then by change of subject, you would know that if you multiply this by the N, right? Yes, you know that the product of the moles and then the molar mass should give you the mass. Now we are seeing that the M here is directly proportional to the N, and that can be derived from here. That the N and the M are directly proportional. The N is also directly proportional to the M. That is derived from here, right? Now the N is equal to 1. That is the small n, right, is equal to 1. Good. Now if it's equal to 1, the mole is equal to 1, then we are saying that the molar mass is the same as the mass. And so instead of writing the amount of substance here, we are just changing it directly to the mass. We are changing directly to the mass. So we are saying that the mass, now you don't really have to necessarily worry your head with all these explanations. What you should know is that the mass of the substance, that is the molar mass of the substance, right, in 1000 ml will produce 1 molar of that substance, such that if I want to produce 1 molar of NaOH, because the molar mass of NaOH is 40 grams per mole, because it's 40 grams per mole, if I take 40 grams of the NaOH, put in 1000 ml, I'll produce 1 molar NaOH. Very simple. The statement here we have to pay attention to, that is the assay or purity. Now, this is only true if the purity is 100%. It is only true if the purity is 100%. It means in any other purity apart from 100%, there should be factored, or it should be factored. That means we cannot just conclude after our equivalent calculation. We have to factor the assay if it's not 100%. Now, we are seeing the mass of a substance, that's the mass or weight of a substance in 1000 ml, we produce 1 mole of a substance. Now, there are things we have to note when we are doing this equivalent calculation. We are saying that if you change the concentration portion, directly affects the mass. So if you change the concentration here, it will directly affect the mass, but then the volume will not be affected. Now, if you change the volume section here, it will also affect the mass, but the concentration will not be affected. Right? Good. Then I said the expression treats the compound in the question as 100% in terms of purity. The actual purity of a substance should therefore be factored in correcting. So I said if it's not 100%, you cannot take the value that you got here after doing equivalent calculation, but you have to what? Factor the assay or purity before you pick your volume to prepare your solution. Good. So we have samples to try. Now, we are being asked to prepare 500 ml of 0.1 acetic acid solution. Now, the purity is 99.7. The molar mass or the molecular weight is 60.005 grams per mole. Then the SG, that is the specific gravity, is 1.05 grams per mole. Now, usually we give you density if we realize that the reagent you are using is a liquid, because we know that density can convert the mass to volume for us, because density relates mass to volume. And so when you see a density in any neutral question, then you should be thinking of the fact that the reagent exists as a liquid. So from our literature, let me just share a white screen and then we'll solve the question. Okay, so this is what I'm supposed to do. Now, the first thing, I know the mass of the acetic acid, the CH3COOH, in 1,000 mils should produce 1 molar CH3COOH. This is the first general statement. Now, the molecular weight has been given, so 60.0050 to 4 decimal place grams in 1,000 mils should produce 1 molar CH3COOH. Very simple. Now, the first thing I have to do, or in no particular order, is to check the volume here. Now, the volume here usually represents the volume of the volumetric flask I am using in my titration. So I have 1,000 here, the volumetric flask is about 500. I have to divide it by 2 and then divide the mass by 2. The mass by 2 will give me 30.00205 grams, directly proportional to 500 mils, which is also proportional to 1 molar CH3COOH. We said that if you change the volume, it will affect the mass, but will not affect the concentration. Now, the concentration I want is 0.1, but then I have 1 here. So what I can do is that I can multiply by 0.1 or divide by 10. All right, so if I multiply by 0.1, this will be 3.0003 gram. Now I've rounded this up because we are supposed to leave it in 4 decimal place. If I maintain the 2 and 5, it will be what? 5 decimal place. So I'll round it off and then add it here. So this one in 500 mils will produce 0.1 molar acetic acid. Right, good. Now we could have taken this mass directly if it happened that it was 100% pure. But then it's not 100% pure. So what do? We factor the assay. So we are saying that 100% purity would have corresponded to this one. So the 99.7% that we have will correspond to what? Now, usually this percentage, the 100 is always the numerator. So the numerator is, and if I'm not afraid, the 100 is always the numerator for all that I've seen. So you have 100 over 99.7 times 3.0003. I have to punch this in my calculator. So then I'll have 3.0093 grams. Now, this, if I pick this amount, it will actually give me the 100% purity I deserve. Good, good, good. Now, the next thing here is that they give me the density. I told you when they give you the density, it means what we are dealing with is what? S So what we are dealing here is what? It's a liquid. It's a liquid. So let me write it up here. Good. Now we have the mass. The specific gravity is equal to mass over volume, right? So the volume will be equal to mass over specific gravity. And the volume will be equal to, what is the mass? 3.0093 all over the mass. What is the mass? Sorry, what is the specific gravity? 1.05. So then I get the volume being equal to, volume is left in 2 decimal place. So 2.87 mils. So it means I will go and take this amount of the stock solution of the acetic acid, come and then fill my 500 ml volumetric flask, probably to the half mil mark, add my acid. Now I'm filling in water before adding the acid, because we don't add acid, water to acid, but we add acid to what? Water, to ensure this even distribution of heat, right? But so I'll fill my 500 volumetric flask. Now I'm choosing 500 because my total volume was 500. 500 ml volumetric flask, and then I will add my acid quantitatively to it while swelling to what? Ensure uniform distribution of what? Heat, right? And then I'll top it up to the 500 ml mark, cock it, and then shake it and label it appropriately. That's all you have to do. That is all you have to do. So let's go through the slide again. So this is the same thing that has been stated in the slide. Very simple. The same thing that has been stated in the slide. Very simple. Good. Now, another question. So this question asks us to prepare 8 liters or 5 molar NaOH solution, has given us the purity, and then we have the 40 the molar mass of the NaOH. So we are saying that the molar mass in 1,000 mils, the molar mass in 1,000 mils should be 1 molar NaOH. Now, because I want 5 molar, I'll multiply this one by 5. It will affect the mass. The mass will also be multiplied by 5. I'll get 200. Then the volume is supposed to be 8 liters. So I'll multiply by 8 to get my 8,000. And then this one will be 1,600 or 1,600 grams. Then because this one will correspond, or would have taken this one if it was 100% purity, right? But then it's not 100%, it's 98%. So 98 will be what? So we just scale, right? And then we get 1632.6530 grams, right? Good. Now, because this is a solid, you realize that there is no specific gravity stated. There's no specific gravity stated. Right, good. Now, when it gets to the preparation, you can just fetch your sodium hydroxide, dissolve it in a small amount of water in a beaker, right? And then you can now fill your volumetric flask, the 8 liters volumetric flask. Then you can add your solution to it. Then you can top it up to the 8 mil mark, 8 liter mark, and then you cock it, shake it, you cover it, and then you label appropriately. I'm saying cover a lot, but then that's it. So you can try this question. It's the same type of question. Try it and show it to your teens or your friends or even myself. I'll be glad to help. Good. The next thing, standardization.